Hello students, we are going to start chapter 13, electric current and its effects. In this chapter, we are going to study about electric current, heating effect of electric current, magnetic effects of electric current. First, electric current and electric circuits. What are electric current and electric circuits? Electric current, the flow of charge through a circuit. Whenever a charge flows through a circuit, we say that electric current is flowing. So, electric current is nothing but flow of charges. SI unit of electric current is ampere. So, we measure the electric current in amperes, like we measure the length in kilometers, liquid in liters, okay, then distance in meters. Similarly, we measure electric current in amperes, and ampere is denoted by the capital letter A. Next, electric circuit. What is electric circuit? A complete path for the flow of electric current. A path which shows the electric current is flowing is called as electric circuit. We have two types of electric circuit, open circuit and closed circuit. Open circuit, if any part of the circuit is broken and electric current does not flowing through it, such circuits are called as open circuits. So, open circuits are nothing but if the circuit is broken in between and it is not allowing the current to flow through it, then such circuits are called as open circuits. And closed circuits are opposite to the open circuits. If there are no breaks in the circuit and it provides a closed path for the flow of the electric current, and such circuits are called as closed circuits. So, if there is no break in the electric path, then electric current will flow, then we called it as closed circuits. Next, components of electric circuits. What are the components of electric circuits? The components of electric circuits are cell, battery, switch, electrical appliances, wires, etc. We know cell, battery is the combination of two or more cells. Switch, we know electrical appliances, you can take any electrical appliances like bulb, fan, TV, and wires. So these are the components of the electric circuit. Now, what is circuit diagram? Circuit diagram is the systematic diagram that represents an electric circuit showing using the standard symbols of component used in the circuits is called as circuit diagram. A systematic diagram that represents an electric circuit is called as circuit diagram. Next, heating effects of electric current. Whenever the electric current is passed through any electrical appliances, suppose if we switch on the light, after 10 minutes just touch the light bulb, switch off the light and just touch the light, then what you will see, it produces light and and in the same way it also produces heat. So we are going to study about heating effect of electric current. Heating effect of electric current. When electric current is passed through a conductor, it produces the heat in the conductor, and this effect is called as heating effect of electric current. So whenever the electric current is passed through a conductor, conductors are those which conducts the electricity, it produces heat. So it always, electric current, whenever it's passed through any electrical appliances, it always produces heat in the conductor, and this effect is called as heating effect of electric current. Example, electric irons, heaters, hot plates, greasers are the some electrical appliances are used which works on the heating effect of electric current. Next, electric fuse. What is electric fuse? A fuse is a safety device made of material with the low melting point. It protects the electric circuits and the devices in the circuits from excessive current passing through them. Okay, fuses is a safety device made of the material with the low melting point. It should be made with the material with the low melting point, and it protects the electric circuits and devices so that whenever the excess of current is passed, then what happens? It will not spoil the electric appliances, and the electric fuse get spoils. Because why? Because it is made up of with a metal which has a low melting point. Next, electromagnetic and the application. Electric current has a heating effect. Similarly, it has also the electromagnetic effect. An electromagnetic is a device that acts as a magnet when current flows through the coil. So it is nothing but it is a device which acts as a magnet. Magnetic effects. It shows the magnetic effects. It consists of magnetic material such as soft iron and a coil insulated copper wire tightly wound round it. The material on which the insulated wire is wounded is called as core. So what we do, we take a material that is a soft iron piece and a coil of it is made up of copper wire which is tightly wounded around the iron. The material which the insulated wire is wounded is called as core. It is a temporary magnet and loses its the magnetic property when the current is withdrawn. So it is not a permanent magnet, it is a temporary magnet. So as soon as the electric current stops, it loses its magnetic properties. Application. It can be used in the electric cranes to lift the iron scraps, an armature of electric motors, an electronic device such as televisions, radios, tape recorders, MRI scanning machines for the medical diagnosis. So MRI machines are nothing but they are magnetic resonance machines. So they are also based on the electromagnet property. Next, electric bell. An electric bell is a device that works by the means of electromagnet. So electric bell is nothing but it also works on the property of electromagnet. It consists of electromagnet armature made of thick iron bar fixed on a spring and makes and breaks the arrangement when the screw and iron and an iron strip. So it consists of an electromagnet, an armature of thick iron bar which is fixed on a spring, make and break arrangement with a screw and iron strip. So here electric bell, in this diagram we have shown the electric bell. This is switch, this is switch, this is battery, this is electromagnet, this is gong, this is hammer. Okay, so this is the electric bell. So when the switch is on, that is when the switch is pressed, what will happen? The circuit is closed and the current starts flowing. The current starts flowing through the current starts flowing through the coil. First it flows through the coil of the electromagnet. It acts as a magnet and pulls the iron bar towards it. So now what happens? It acts as a magnet and it pulls the iron bar towards itself. Then the hammer is attached to the iron bar, strikes the gong. This hammer is attached to the iron bar. It strikes the gong. Due to the motion of the iron bar moves and the iron strip loses its contact from the screw. So this iron bar loses its contact from the screw and hence the circuit becomes broken circuit and the current stops flowing through that. Due to this, electromagnet loses its magnetic power and iron bar which is attached, this iron bar which is attached to the spring moves back. This iron bar, it moves back and it comes to the initial position. So this making and breaking of the circuit continues. Then the making and breaking of the screw continues. Circuit continues till the switch is kept pressed. Until you keep the switch pressed, this making and breaking of the circuit continues, and the hammer will repeatedly hit the gong to make a ringing sound. This hammer hits the gong and make a ringing sound. In this way, the electric bell functions. So this is the diagram of the electric bell. Till here, your chapter has been completed. Thank you.